All right, so for 8.4, inscribed angles. We've got some cool stuff for inscribed angles today. Yeah, really? All right, so we're going to verify the relationship between an inscribed angle and its intercepted arc. Kind of. We're going to find the measures of inscribed angles and their intercepted arcs, and we're going to verify and apply some other relationships for special cases of inscribed angles. All right, so first of all, an inscribed angle is an angle whose vertex, let me get a pen here, actually, okay, whose vertex, still don't have a pen, this is awesome.
I do.
Okay, there we go. Vertex is a point on a circle. So which one of these angles is inscribed?
V.
V. So name the whole angle.
UVW.
UVW. Good. UVW is inscribed because its vertex is V, like you guys said. All right. The other thing it says is its sides contain chords. Okay, so angle LKM is not inscribed because its vertex is the center, bless you. What kind of angle is LKM? Goes through the center.
What's that called?
Center.
Central angle.
Central angle. Okay, so angle LKM is a central angle. Angle UVW is inscribed. Okay, so there are a couple different cases of this. Okay, it doesn't really matter, but just so you see them. So we can have an inscribed angle where the center is on the inscribed angle, right? It's on the chord. So in this case, that chord is a diameter. Okay, we can have it where the center is interior to the inscribed angle, or it can be exterior to the inscribed angle. It does not matter. So just so you know, the center can be anywhere. The only thing that matters is that its vertex is on the circle and its sides are chords. That's what makes it inscribed. Okay, then we have the inscribed angle theorem. The measure of an inscribed angle is 1/2 the measure of the intercepted arc. So the measure is 1/2 the measure of the intercepted arc. So, example 1a. Find each measure. So we want the measure of angle VYW.
So it would be 30.
How'd you get that? It equals what? Use the theorem to help you out.
Because it's the arc is 60.
The arc is 60 and the measure equals 1/2. So it's 1/2 of 60 equals 30 degrees. Correct.
Equals 30, you know. 30.
Why do I have the sheet? Okay. How about for the measure? What's B? What are we finding in B? The arc. Okay, so in B we're looking for the arc WX.
110? Oh no, it's just 110.
Okay. WX. All right, where'd you get 110 though? Hold on.
It'd be 50.
Okay, so let's take this a little further. Where'd you get 110 from?
Because
55 plus 55.
Okay.
Equals, and then do minus 60.
All right. So, so what arc would that be?
the 60 would be from B to X.
Okay, so arc, the measure of Vx would be 55 times 2, which is 110. That is excellent. And then you said, oh, well, we could subtract, right? So 110 minus 60, and this is for the measure of arc WX, is 110 minus 60, which is 50 degrees?
Yeah.
Nice job. Good connections. Very good connections.
Thank you.
Yeah.
I did one finally. You said the answer, but I couldn't.
All right, everybody got it?
Yes, I did.
Does everyone have it written down? Okay. Then, go figure. All right, then we have a couple other theorems here.
She got a light.
Pardon me, a few.
Teacher does.
False. All right. So these three theorems, incongruent circles, or the same circle, inscribed angles are congruent if and only if they intercept congruent arcs. Okay, that makes sense, right? We've talked about those. kind of before with all of our other angles and our arcs. Sorry, congruent arcs. The next one, an angle inscribed in a semicircle is a right angle. Well, that makes sense, right? Because a semicircle is how many degrees? 180. So the arc for a semicircle is 180. And we just learned in our previous theorem that it was 1/2 of the arc it intercepted. So it makes sense that an inscribed angle in a semicircle is a right angle. Okay, we can use that other theorem together. Are we okay with that? No? Okay. So if we had a circle, right, here's our diameter, and we had an inscribed angle here. This angle is a 90 because it's inscribed in the semicircle.
Okay.
That make more sense?
Yep.
Okay, perfect. All right. Then the last one, opposite angles of an inscribed quadrilateral are supplementary. So opposite angles of an inscribed quadrilateral are supplementary. So if I made this into a quadrilateral, then these two angles, right, add up to 180. Doesn't matter what shape it is, but they would be 180. So supplementary, you might want to write 180 degrees in there to remind you supplementary is 180. Okay, so example 2, we're going to find each measure in figures of with circle P, where arc DAB. So I'm going to go ahead and write that arc DAB. Is that a major arc or a minor arc? Major. Okay, equals 208 degrees. Okay, that is a major arc. Good. All right, so what's the measure of angle ABC? What's the measure of angle ABC? Okay, so think about its chords. What do you notice about this?
It's 90.
Okay, because what is this right here?
Oh, okay.
That's the diameter, right, that cuts it in half. So this is a semicircle.
So like,
This is ABC is inscribed in the semicircle. Okay, so I'm going to erase all those extra lines there. Yes, so it is 180. Okay, because so this equals
Now, why would
1/2.
180?
Sorry, it's 1/2 of 180.
yeah.
So it equals
90.
90 degrees.
Oh, I'm not getting there.
Sorry. Good. Measure of angle BDC. I want you to
34.
kind of forget this there as well. All right.
Why?
It's not very helpful.
You said it too fast, but she's like, he knows to get rid of it.
No, that's not the right measure. I mean, acute angles of a right triangle are always complementary, right? Because complementary is 90 degrees. But I was like, that's not really helpful necessarily. So let's walk through angle BDC. Angle B, the measure of angle BDC.
I thought you said we weren't doing it.
No, we're doing it. It's just that's not a helpful hint.
Oh.
Sorry, it's just the hint is not helpful.
No, well, I crossed off the whole I can't do it.
Oh, gotcha. You know, well, you can do it.
No, I
Yes.
can't, no.
Yes. Yes, yes, yes. Because see, here's the thing. Why I say this is not helpful. Acute angles of a right triangle are complementary. Okay, great. But how do I know that that's a right triangle? It doesn't look necessarily like a right triangle. How on earth would you know that triangle BDC is a right triangle? So having this hint isn't really helpful until you know that it's a right triangle, which it doesn't give you. So that's why I'm like, this is not really helpful.
Would angle C be right angle?
Why would you think angle C would be a right angle?
It looks kind of right.
It looks kind of right.
You kind of look more sideways and it doesn't look very right.
Got anything more than that for me? It does have to do with these three theorems up here. AC is the diameter, yeah.
So,
And that's how we knew that ABC was 90.
yeah.
But
We don't have A in this one, though.
yeah, but I say we don't have A in this one. And if we did, then angle ADC is 90. But that doesn't help us with BDC.
DC is perpendicular to CD.
What was it?
DC is perpendicular to CD.
BC is perpendicular to CD. Why is that?
It doesn't look perpendicular.
Why?
Because the other lines are parallel to each other.
Doesn't say that anywhere. You can't go off of what they look like always. If you could prove to me that BC is perpendicular to AD, I might take it.
That means you're right. Prove it.
But I also said it relates, but that would require it to relate to a different theorem versus one of the three that are currently up there.
Would you use the bottom one? Opposite angles.
Do they intersect congruent arcs?
Okay, opposite angles are quadrilateral. Do we know? So opposite of, let's see, BDC, that's not a quadrilateral though. Like it would have to be this whole angle to be opposite of that one. You know what I mean?
Maybe the fact that it's an angle inscribed in a semicircle.
Yeah.
But it's not. Right, we just talked about that one earlier. It's not inscribed in the semicircle. Because, right, like the semicircle, that's what angle ABC was, but BDC is not inscribed in the semicircle.
You're killing me. So it's the top one.
They're going through congruent arcs.
Say what?
Congruent arcs.
What's congruent arcs?
I don't know.
Okay.
They don't look congruent.
Doesn't matter that they don't look congruent. What does it say?
Incongruent circles, inscribed angles, inscribed angles are congruent if and only if they intersect congruent arcs.
Okay, so looking at this theorem, okay, so if they go through congruent arcs, so angle BDC is congruent to what other angle?
ABD.
Not ABD.
Yeah.
ABD does not go through the same arc, right? BDC goes from B to C, this arc.
So BCA.
Not BCA,
CBA?
not CBA,
What?
because your vertex is on the opposite side. Your legs have to go to the arc.
Oh, your legs have to go to the arc?
Yes.
B.
BAC. Okay, so yes. So BAC. So we know that the measure of angle BDC is congruent to the measure of angle BAC. Because, okay, you're doing great.
68,
Okay, because, okay, I'm gonna write this. Because both intercept arc AB. All right. Now, what'd you say?
Arc BC.
BC, thank you.
She's slacking.
Yep.
We all are.
which
Okay.
equals 68.
Okay, so, okay. BC, which is, I'm gonna write 68 degrees.
Which then the measure of BAC would be 34, because half. And since BAC is congruent, right, to BDC, their BDC equals 34.
Where did you come from? That was awesome.
So why was it wrong when I originally said 34?
Because you didn't show your work.
Okay, hold on. Because it's not 34. Time out. What happened?
Lucas, go back in your.
No, hold on.
1/2 of 60.
Why do I have? Because I did AD. What did I do? AD. I did mine differently. Hold on. Time out. Back the train up. Where's my geometry book? Because I have my answer as 22, but I also had arc AD. I could have been looking at it the wrong way.
Isn't it 32?
32 would be totally wrong. That's half your answer and half my answer. Nope, 22 is correct.
How is 20?
Did I write the wrong? Okay, B, D, C.
All that work, I'm gonna cry.
Hold on. Let's see.
Confused why y'all need to do all that.
What is the angle of B, D, C?
You like my socks? They're blue. Okay.
Purple and green.
I have another pair that's purple and green. There's a poster that is
Hold on, B.
from the Elmo movie, you know?
All right. What do you think about that?
Grouchy.
Look at, okay, so here's my mistake. I was like, we did everything right, except
68 is that triangle.
68 is the angle in there, not the arc measure. Right. So that's why.
They need to do a better job at drawing a line.
Well, I covered it up and like then went with it until I realized like, wait a minute, this is not correct. So yes.
Are you done?
No, we're not done. The information we have is fantastic.
Well, I already erased it.
Okay.
So,
No, I'm just kidding.
But just 68 is where we went wrong.
So let's redo it.
So what is maybe BC?
Well, 68. Because you do.
so is the angle 68?
Yeah, the C angle is 68.
Yeah, the C angle is 68, but 68 is this measurement right here is 68. Yeah, so it's not the arc measure. Well, let's just. Okay.
So
We're still looking for angle BDC.
so 136 is one arc. Is that one arc from B to A is 136. I don't know if we need it, but might as well put it.
What was it?
The arc from A to B is 136.
How'd you get the arc from A to B as 136?
Because the angle.
What?
This.
Well, you know
But the
that was-
68 is this angle. See, that's the thing. Like these are all overlapping.
So,
No, the 68 is the C degree angle. So.
Well, it's not. Okay, there's not one C degree angle. The 68
Is that triangle?
is
it's just C.
this angle in here. It's from this chord to this one
Yeah,
is
that's
68.
what I'm saying. The
Okay.
arc would be 130.
So you're saying from A to B here.
Yeah.
Okay, so that's what I'm trying to piece together. So you're saying that arc, so arc AB equals twice of this, 2 times 68,
Yes.
which would be 134, you said? 136? Okay. All right, I'm down with that.
So then you get 44 as the arc from B to C.
Okay. Are we following this? Are you guys following this? It's okay to say no. That's not how I solved it. It's okay. Okay, so let's go back through for a second. All right, so we'll erase all of our other stuff. Okay, so we know ACB. This angle is 68. We're good with that. Okay, it intercepts arc AB. So 2 times 68 is 136. So this arc length has to be 136 degrees. We good so far? Okay. Then we know that AC is a diameter. So the arc AC has to equal how many degrees? 180. So what is arc BC?
So it'd be 180 minus 1.
Yeah, because we could take arc AC minus arc AB, and that's going to equal arc BC. So 180 minus 136 equals 44 for arc BC. Okay.
So that means that measure BDC equals 22.
So BDC, so the measure of angle BDC would equal 1/2 of 44, which would be 22 degrees. That is the correct answer. Again, not how I solved it. Not how the book solved it. Not wrong. Okay. Because
Never solve anything like the book.
I don't usually either, quite honestly. That's why I always struggled with math in school.
I'm gonna grow up to be a mathematic genius.
You might.
Struggled in math.
Hey, it's possible. So, what I did was I looked at triangle ABC, because we had already said angle ABC was 90, and this angle was 68. So I just did 180 minus 90 minus 68 had to equal the measure of angle BAC. And then because I already knew BAC was congruent to BDC, whatever I got here, 180 minus 90 was 90, 90 minus 68 was 22. So whenever I found the measure of angle BAC, I also had the measure of angle BDC. So either way, but like that's the thing with geometry is you have to look at like this relationship, because there's a quadrilateral in there, there's multiple triangles in there, like 4 technically triangles, and the circle, and just like, okay, how are these related? How can I use one to help me solve this one? And you just keep going. All right, so awesome work on that one. C, we want to find the measure of angle DAB. Yep, measure of angle DAB. So let's erase the junk I've got on here for now. I should start giving you like the same picture for each individual problem. All right, you would like that, so then you wouldn't have to erase all the time. So D to A to B.
We can also like understand what we did.
Right. And remember, we know that this arc is 208 degrees.
Why do we know that?
It told us here. Angle DAB
Oh, yeah.
is, arc DAB is 208 degrees. So how much is angle DAB?
Wait, couldn't you just...
Yes.
So, do B to C, and that's 44.
Okay, so why would I even do B to C?
Just do it.
No, we're making it harder.
She quite literally just told you no.
I'm just teasing. I'll put it up there.
No, it's going to make it harder.
Okay, so we discovered that B to C is 44 degrees.
How did you know what he wanted? He didn't even say the number out loud yet.
Yeah, I did. He said BC is 44.
I'm losing my mind.
Because you guys just solved for that over here.
Trust me, girl, you lost a long time ago.
You could add those, and then you could find the total circumference.
No!
I'm just kidding.
But like that's the thing, is that we need to know this measure right here.
Why do you need to know that?
Because the
So,
inscribed angle is half of the arc it intercepts.
But why is
So
that
would
the
you do
inscribed angle?
208?
Because
Oh, yeah,
this is the
I
chord.
get it.
Those are the vertexes. Say it.
What would you do 208 minus 1 minus 360?
The other way. 360 minus, yes. Okay. So 360 minus 208 is going to give me the measure of arc BD, right? That's the arc we want because that's what it intercepts. So what is 360 minus 208?
152.
Okay, so 152 equals the measure of arc BD. Now that I know that, Justice, how can you finish it? Now that we have the arc measure, how does that relate to angle DAB, the inscribed angle? Don't listen. Like I thought today was going to be so fast.
Okay.
Oh, you already added the purple. Okay.
Yeah.
That's what she just did.
Lucas.
Would you divide
No, next.
52 divided by 2?
Yes, because the inscribed angle is half of the arc that it intercepts, and it intercepts this arc.
76.
So the measure of angle DAB equals 152 divided by 2, which is 76 degrees. Very nice. Lucas is on fire today.
Lucas took our mojo. He beat us in civics government too.
Nice. All right, well then you guys can start on your homework, page 372, 1 through 29. Odds only.